It is time for us to start looking at the topic 10 review. Once again, this is a from scratch video for me. I don't have an answer key that I'm looking off of, so it might take me a little bit longer and I might make a couple of mistakes that I have to go back and correct. So bear with me here, but we should get through all of this. So number 2 here, a blank is a region of a circle with 2 radii and an arc of the circle as its borders. That would be a sector of the circle, or a pizza slice, like I like to call it. So sector. The next one, a blank is an angle with its vertex on the circle. That would be an inscribed angle. A blank and the corresponding circle have exactly 1 point in common. That would be a tangent because it hits the circle at 1 point. Number 5, when both rays of an angle intersect a circle, the blank is the portion of the circle between the rays. That would be the intercepted arc is the portion of the circle between the endpoints of a central angle. So that is the intercepted arc. Coming on down here, find each arc length in terms of pi. So number 6 here, we've got 112 degrees over 360 times 2 times pi times 5. And then in terms of pi, let me go ahead and pull up a fraction for that. 112 over 360 times 10. That should be 28 over 9 pi. Number 7, we've got arc ABC. That's the other one. So that's the major arc. So first we do 360 minus 154, and we get 206 degrees for the minor arc, or the major arc. So 206 over 360 times 2 pi times the radius of 8. So that would be, just using my calculator here, it's going to be 412 over 45 pi. 8 and 9 are sector areas. So for number 8, we've got sector NRM, so 63 over 360 times the area formula, pi times 10 squared. That's going to be, let's see, 63 over 360 times 100. That's 35 over 2, or 17.5 over 2 pi. Number 9, sector DSE, that is 172 degrees. So 172 over 360 times pi times 7 squared. Should be 2,107 over 90. Over 90 pi. There we go. Number 10, if you know the circumference of a circle and the area of a sector of the circle, how could you determine the central angle of the sector? We would just use the formula that we know. So if we know the circumference of a circle, we can go backwards on the circumference to find the radius. So we can take the circumference divided by, since that's 2 pi r, divided by 2 pi gives the radius. And then we would also go backwards on the area of the sector. So we would say, we know that central angle measure over 360 times times pi r squared is the area of the sector. So pi r squared equals the area. And then we'd take this and we'd say solve the equation for the central angle measure, because at that point we would know the area and we would know the radius, and we would solve that radius for the central angle measure. Numbers 11 and 12, we're trying to find the values. So we're trying to find QR here. We know that another radius of the circle is PQ, which is 7, and we know there's going to be a right angle between a tangent line and the circle. So we will look for x squared plus 7 squared equals 13 squared. And if we solve that equation, we will find that x equals, well, I guess I have to solve the equation first. So we've got x squared plus 49 equals 169. X squared equals 120. And then we would find the square root of that. So x is equal to whatever the square root of 120 will be. And you could have your answer as a decimal. That's totally fine. Number 12, the measure of angle CAB. If this is tangent, we know there's a 90-degree angle there. So all we need to do is the remaining 90 degrees of the triangle minus 58 degrees. So we're finding the complement of 58 degrees. And that's going to give us 32 degrees. Number 13, if GH is a diameter of T, is it possible to draw tangents to G and H from the same point external to circle T and explain? So if we have a circle and GH is a diameter, can we draw tangents G and H from the same point external to T? So if I have a point out here, am I able to draw tangent lines to both sides? And in this case, I am not able to. I'm not able to get to both sides. I can get really close, but this is the idea we'd be going for with tangents. Of course, I'm connected to a grid here, so I can't make it exact. But we won't be able to, because in order for these lines to touch the diameters exactly one time, they have to be parallel. And no points that ever connect are going to be parallel here. We did an explanation of this as the first example in one of our sections this chapter. But we would say that if lines were tangent to both G and H, they would be parallel. So if lines were tangent to both G and H, they would be parallel. And since they were parallel, they would never intersect at a point outside the circle. And would never intersect. So the answer technically is no. Number 14, segment MN is tangent to circle L. What is the radius of the circle? So in order to find that out, we've got the right angle here. We know we know 8 centimeters. The radius is called x, so we can draw it here as well. And then we can use the Pythagorean theorem. 8 squared plus x squared equals x plus 5 squared. So that's going to be 64 plus x squared. We need to use the FOIL method, or distributive property, for x plus 5 squared. That'll give us x squared plus 10x plus 25. Then I'll cancel x squared from both sides, or subtract x squared from both sides. So 64 equals 10x plus 25. Subtract 25. Can you believe I need a calculator to do that? That is 39 equals 10x. And then we will divide both sides by 10 and get 3.9 equals x, or 3.9 equals the radius. Numbers 10 or lesson 10-3 problems with chords here. The radius of circle T is 7. Find each value, round to the nearest tenth. So if the radius is 7, I can draw it in various places that could help me. If I'm trying to find FH, I'm going to need to know, since this entire radius is 7, I'm going to need to know this distance. But since I see that these chords are the same length, then I know they're the same distance away from the center. So I know that FT is 5. And since the entire radius is 7 and FT is 5, FH is the rest of it, or 2. CD I can find by making a right triangle with the 7 radius and the 5 that I know, and using the Pythagorean theorem. So 5 squared plus x squared, the other leg, equals 7 squared, since I know there's a right angle here. And that'll be 25 plus x squared equals 49. And that's going to give us x squared equals 24. Round to the nearest tenth when we take the square root. X equals 4.9. So CD is equal to double that, because CF is 4.9. Doubling that is going to be 9.8. And finally, the measure of angle BTA. So we know that the measure of arc CH is 44, which means the measure of the central angle here is 44. Then we need to get to BTA over here. 44 is going to be the same as all of these little half angles here. So BTG is 44, and then GTA is 44. And if I add both of them together to find angle BTA, that is 88 degrees. Number 18, circles T and S intersect at points A and B. What is the relationship between segment AB and the, what will we call it? We would call it the segment between the center T and the center S. So there's that segment. And then the circles intersect at points A and B. And if we are going to make the segment between them, what we're actually creating is the perpendicular bisector, because what we've just made is a copy of the perpendicular bisector construction that we always do with our compasses when we make a perpendicular bisector, where we take a compass, we swing an arc up from one point on the end point of the segment, we swing an arc up from the other point, and then also down, connect them together. So this is the perpendicular bisector. AB is the perpendicular bisector of TS. Number 19, a contractor cuts off part of a circular countertop, so if it's against the wall, what should be the length of the cut round to the nearest tenth? Well, I see that 120 is the diameter here. So if I draw a center, and this is only 100 centimeters instead of 120, I still know if this is the center of the circle, that half of the 120, or 60, lives down here, which means 40 of those centimeters are between the center and the countertop, or the edge of the countertop. And I also can draw another useful radius to make a right triangle. That's 60 centimeters. So then I'm using the Pythagorean theorem. X squared plus 40 squared equals 60 squared. So x squared plus 1600 equals 3600. Subtract 1600. X squared equals 2000, and I'm rounding to the nearest tenth with my square root. So x equals 44.7. And that's only for half of the counter, for half of that edge. So we'll need to make sure to double that so we get the entire length of the cut, the entire length of the cord. So then the cord is equal to double that, which is 89.4. Okay, 10-4. We've got inscribed angles here. We've got the measure of arc EF, and it looks like angle EDF and angle FGE are both inscribed angles with a common arc. That means this angle and this angle are the same amount, the same degree measure, and if I find out the degree measure, I can solve the problem. So 5x plus 14 equals 9x minus 6. So 5 equals x. I can plug 5 in for one of the angle measures. So 5 times 5 plus 14, 25 plus 14 equals 39. So these angle measures are each 39 degrees. I'm going to multiply them by 2 to find arc EF. So that would be 78 degrees. Equals 78 degrees. Next, I'm looking for the measure of angle MNP, so I figure out which angle that is. That's this one right here. And I've got a lot going on here. I have a tangent chord angle, MNP. How am I going to do that? Let's see. So I know that this 51 degree angle is right here. So PN is a 102 degree arc. I know that NM is a 163 degree arc. And I know that there is a right angle here. That's going to be another tangent chord angle, but it doesn't go all the way over. So what's that going to mean for me? Let me think. So if I can find this arc measure, I can find the angle measure. Oh, that's easy. I'm just finding the rest of the arc measure here. So I'm going to take 360 degrees minus 163 minus 102. And find that last remaining arc is 95 degrees. Since that arc is 95 degrees and it is the intercepted arc of a inscribed angle, then the inscribed angle, MNP, is half of 95. So 95 over 2 is going to give me 47.5 degrees. Number 22, the measure of angle WZY. WZY. Well, we know that the opposite angles in an inscribed quadrilateral add up to 180. So I can say that 6x plus 9x equals 180, or 15x equals 180. So when I divide by 15, that means that x equals 12. And then I can use that because I know that these two, z and x together, will be equal to 180. So I can plug this in for z. 8 times 12 plus 5, so that's 96 plus 5, or 101. And then I can do 180 minus 101 and get 79. So z is going to be that. It's going to be the supplement of x. 79 degrees. Number 23, the measure of angle QPR. Here's QPR. So let's think here. I know that there's a triangle over here, and it has 71 and 59 degree angles. So I can find the third angle of this triangle by doing 180 minus 71 minus 59. 180 minus 71 minus 59 is 50. So this angle measure is 50, and it's an inscribed angle with the intercepted arc of RSQ. So arc RSQ is double, or 100. Angle QPR is also an intercepted arc, or an inscribed angle with intercepted arc of QR. So this is going to be half of 100. So angle QPR equals 50 degrees. Number 24, if a rectangle is inscribed in a circle, what must be true about the diagonals of the rectangle? Explain. So here's a circle, and we'll have a rectangle inscribed in there. It says, what must be true about the diagonals of the rectangle? So here are the diagonals. Well, there's a few things. I'm not quite sure what they're looking for here, but since those diagonals intersect at the center of the circle, each of the diagonals is a diameter of the circle. So that might be what they're looking at. We already know that the diagonals of a rectangle are congruent, so it's not asking if they are congruent. I think what it wants us to tell them is that these are going to be diameters because they're going to pass through the center of the circle. So we can say they will be they will be diameters of the circle. They will be diameters of the circle. And there may be more than that, but that's not going to be a very important question anyway. Lesson 10.5, we've got some segments and some chord angles here in this first problem. So we want to find QR. We know 3 pieces of these segments of our chord angles, so we will say that 5 times 12 is equal to 10 times x, the missing piece. 60 equals 10x divided by 10. 6 equals x. So QR equals 6. Then to find the angle, the measure of angle NRP, we have these two intercepted arcs for this pair of vertical angles. So we're going to say half the sum of the arcs, 43 plus 81, is going to give us our answer. And what that will be is 62. So the measure of angle NRP is 62 degrees. Down here, we've got a tangent secant thing going on. So we want to find WZ and the measure of arc XZ. For WZ, we know this piece on the outside, and we know this piece on the inside. We're just looking for this WZ piece. And to do that, I'll call it Y. I don't know, that's not a good variable. We'll call it A. So to find A, we're going to say, oh, in a tangent secant relationship, I know that the outside piece of the secant multiplied by the entire secant is equal to the outside piece of the tangent multiplied by the whole tangent, and those two happen to be the same value. So 8 times the whole secant 18 is equal to the tangent multiplied by itself. So 8 times 18 is 144. And then we take, of course, the square root of both sides, and 12 is equal to the missing value WZ. The measure of arc XZ is going to be this arc right here. I know the larger intercepted arc, and I know the angle, so I can make an equation finding the arc. I can say 1/2 of the larger arc, 187, minus the smaller arc I don't know, is equal to the angle 74. Multiply both sides by 2 to get rid of the 1/2. So that's going to be 187 minus x equals 148. Subtract 187. Negative x equals negative 39, so x equals 39. That arc is 39 degrees. Number 29, a student said that if angle A is formed by two secants intersecting outside of a circle, then the measure of angle A is equal to 90. Let's draw this because it doesn't make any sense in my head right now. So there's a circle, and the two secants are intersecting outside of the circle. Let's think about that. That could mean here is a secant, and here is a secant, and they intersect outside of the circle. Oh, then the measure of A, not equal, it's less than 90. So the student is saying that this measure has to be less than 90. And if we're having that be less than 90, that means that this outer arc minus the inner arc divided by 2 is less than 180 degrees. And if we think about whether there could be a more than 180 degree difference between these two arcs, there really can't, because these arcs are only going to be able to go through the circle if they are if they're closer together, basically, than the tangent lines going outside of the circle and hitting it one time would be. The tangent lines can't make a 180 degree arc, so these angles can't make a 180 degree arc either. Is that a really good explanation? I'm not sure. I'm thinking maybe 29 is probably not useful for us and not applicable to the test. So I'm going to go ahead and cross that one off for us, because we're really not going to need to know that information to that detail about secants. Number 30, find CD. We've got these chords going on. If I know these chords are the same distance away from the center, and I know AB is going to be 30, then CD is going to have to be 30 as well. Number 31, find FG. I have a chord here and a chord here. They're the same distance away. And if EG is 21 times 2, FG is going to be that as well, which is 42. Simple ones there. A chord is 12 centimeters long and 30 centimeters from the center of the circle. Let's figure this out. There's the center. Here's the chord that is 12 centimeters long and 30 centimeters from the center. Obviously not drawn to scale, but that's okay. What is the radius of the circle? So if this chord is 12 centimeters long and I've just bisected it, it's now 6 and 6. And to find the radius of the circle, we're going to use the Pythagorean theorem with that right triangle. 6 squared plus 30 squared equals x squared equals x squared, 936. And then if we take the square root of both sides, we're going to find 30.6 equals x, which is the radius of the circle. Number 33, 33 and 34 are our last ones on here. Number 33, 2 hanging walkways pass over a circular lobby in a shopping mall. What is AB? This is a secant segment situation where one piece of the secant, 87, multiplied by the whole secant, 87 plus x, is equal to one piece of the secant, 80, multiplied by the whole secant, 80 plus 210. So we've got 87 times 87, 7,569 plus 87x equals 6,400 plus, well, I won't do that in separate steps. We can just do that all together. Which is going to be 23,000, oops, still on an eraser, 23,200. So we'll solve. And that's going to be 87x equals 15,631. Divide by 87. X will be equal to 179.7. Here we go. And the last one on this review. If the measure of arc JK is equal to 65, KL equals 44, and LM equals 167, what is the measure of angle Z? Well, we're going to need to find the last arc in the circle by doing 360 minus these. So 360 minus 65 minus 44 minus 167. It's going to give us an 84-degree arc over here. And then that is a secant angle, so half the difference of the arcs. 84 minus 44 is 40. Half of 40 is 20. So the measure of angle Z is 20 degrees. And that's all that we have here. Make sure you take a look through. If you've got any questions, of course, let me know. And hopefully that will make it so that you are ready for the test next time that it is. All right? Have a great day. See you later.